Alrighty, so here let's take a look at, we'll practice some working down, why we want to do it, how it benefits us, and how it looks, whether we're working with expressions or equations. This is probably suitable whether you're grade 9, grade 10, grade 11, grade 12. Any time you're looking to review your working down, you stand to benefit from this here. And first we'll ask ourselves why we're looking at focusing here, and that is really math. When it comes down to it, math itself is a language. It's used for communicating patterns we find, patterns we're observing or we're predicting between mathematicians. And that is, if it's used for communicating, then we're looking at ways to improve our writing and our speaking. And so what mathematicians did is they developed methods for showing their steps to one another, and one of those methods was working down. That looks, again, differently whether working with expressions or equations. So right here, first I want you to identify whether these are expressions or equations. Good, these are expressions because they don't have any equal signs, and really because they don't have something on two sides of an equal sign here. This very first expression, we're going to work to simplify this, and we'll work to simplify this. The only key skill the only prerequisite skill you need to use here is your BEDMAS. So we'll follow our BEDMAS here. We'll solve the same problem in showing our work in two different ways. According to our BEDMAS, as we work through this question on the left, according to our BEDMAS, we need to make sure we handle the brackets first, right? So 2 plus 11, that's 13. According to our BEDMAS, we need to handle our multiplied by 3 next. So 13 times 3 is 39. Sorry, that should say times here. And then according to our BEDMAS, we now need to handle 4 minus 39. And 4 minus 39 is negative 35. So good job, us. This is what it looks like if we're not working down, where we have still followed all of the appropriate steps. We still have come to a conclusion, but it's pretty difficult to follow. So let's take a look and see how this solution changes when we're showing our work by working down. When we work down, the first thing we do is we copy. Working down can be broken down into copy and change. So now that we've copied, now we'll want to address, okay, what is that first piece we're working on? It's our addition, according to our BEDMAS. Sorry, it's our brackets, according to our BEDMAS, which in this case is addition. So 2 plus 11, instead of writing 2 plus 11 this time, we'll erase that, we'll write 13. Keep 4 minus 3 times 13, and then change. Well, what's our next step? We perform this multiplication. 3 times 13, that is 39. Copy 4 minus 39 and change. Now in this case, we're changing the entire line because there is only one step left. So 4 minus 39, we're working with negative 35. The entire key is we copy and change, and when we have effectively worked down like this, then we can see every single line is equal to the line above, and we can see exactly what was changed as we went through each line, right? The very first line, we can see, oh, the only part that's different, that's what we did. We performed 2 plus 11. The only part that's different, that's what we did, 3 times 13. The only part that's different, that's what we did, 4 minus 39. So this allows mathematicians to show their steps as they work through. What I want you to do right here is I want you to go in and solve this next problem, which if you're in grade 10, you should be able to handle no problem. If you're in grade 9, depending on where you are in your course, you might have a few challenges. You will need to use your distributive property and then collect like terms. I want you to pause this video here, try it out on your own. In 5 seconds, we'll be going through the solution right here. So, copy, change, right? So we'll start off always with an equal sign, and then we'll copy everything. That's 3x times 2x minus 4 plus x squared minus 1 plus x. Now we're changing things. What would we change first according to our operations right here? Before we add any of our like terms, we'll need to multiply according to our BEDMAS. So we'll need to distribute this 3x into the brackets. Now that is 3x times 2x. So instead of writing this 3x times 2x minus 4, we're going to come up with a change here. 3x times 2x, that's 6x squared. 3x times negative 4, that's negative 12. We've copied, we've changed. Next line. We copy 6x squared minus 12 plus x squared minus 1 plus x. Here we're collecting our like terms. So if we're collecting our like terms, we're looking for pieces that are that have the same variables and same exponents. So that's 6x squared and x squared. So if we are copying and changing, then I'm copying this out. That is, oh, sorry, we've already copied. Now we're just looking to change. So instead of writing this x squared and this 6x squared, we'll add them together. That's 7x squared. And we just write it the once. There we are. We're changing these to a 7x squared. Easy. Now we're copying. That is 7x squared minus 12 minus 1 plus x. Same thing. We're looking for our like terms. We see negative 12. We see negative 1. Negative 12 plus negative 1, that is negative 13. So instead of writing them both out like this, we'll erase and we'll change negative 13. Here, we're all finished. We cannot collect any of these terms anymore because none of them are alike. They have different variables with exponents. So at this point, we've taken it as far as we can. Great job. So if we're working down here with these equations, now we just knew from what we've just reviewed here, we learned that when we're working down, then we want to make sure we start off each line with an equal sign. So I could start off with an equal sign here. I might be tempted to do that, but that only works with expressions. When we're working with equations, we want to line up our equal signs just one below the other, only one equal sign per line, so there's no starting the lines with equal signs in this case. I'm working with 3x plus 1 equals 4. Well, this time I'm going to change this, change each line, but I'll be changing the left side and the right side together here. So I'll be performing, and the prerequisite skill we're using here is inverse operations, and with a little bit of backward BEDMAS here. I'll be trying to work with this addition first, trying to undo that. Well, in order to undo adding 1, I will have to subtract 1 from both sides. Nice and easy. If I subtract 1 from both sides, then I'm left with, and here's my second line that I'm coming up with. The negative 1s, that's just me showing my thinking. But this next line, 4 minus 1, I'm working with positive 3 on the right side. And on the left side, these cancel out. That's good. That was by design. 3x equals 3. If I'm trying to solve for this x value, if I'm trying to isolate it, I'll need to perform, again, my opposite operations. Instead of multiplying by 3 here, I will be dividing by 3. So I divide both sides by 3 down to my next line, where I'm working with x equals 3 over 3. If I put that into my calculator, 3 divided by 3 equals 1. So you'll see right here, not every line is equal, right? Where my very first line, I start off with 4, and then I have 3 over 3, and then I have 1. Not every single line is equal, and at one point this said 3x equals 3, so I even had another third value here. But every single line comes from the line above. It says, okay, well, if 3x plus 1 is equal to 4, then we know that 3x is going to be equal to 3. Well, if 3x is equal to 3, then we know x is going to be equal to 1. So the key here is that every line comes from the line above. Because we're working with equations, not every line is equal to, not every side is equal to the side above, but every line comes from the logic that was included or that was used above. So now I encourage you, maybe pause the video here, try and isolate this x value on your own, try and focus here when you're going to check your work, try and focus on the notation of your solution. Pause the video, come back because we're going over the solution in 5 seconds. Good, so we're working right here, trying to undo these pieces. I will need to undo this 2 first. I start off with that equal sign every single time. I'll be dividing by 2, nice and easy. These cancel out. I'm working with x minus 4 on my right-hand side, and I'm working with 30 over 2. Whoops, 30 over 2 is 15 on my left-hand side. From here, I notice my brackets are not accomplishing anything, so we'll get rid of those. I can undo this minus 4 by adding 4 to both sides. These cancel out. I'm working with x equals 15 minus 4. That's 11. Nice and easy. Lastly, and this one is a grade 9 work here, or maybe you've gone over this in grade 8 as well, but looking at our sum of squares. Again, the focus of this video is not on the concepts that I'm going over, whether it was simplifying or solving or working with our sum of squares, but it's really to focus on how we're writing out our solutions. We might be tempted to write out, remember the relationship for the sides of for the side lengths of a right triangle, which is that the squares of the smaller 2 side lengths of the 2 legs are equal to the the sum of those squares is equal to the square of the longest side length of the hypotenuse here. So a squared plus b squared equals c squared. We're working right here. Let's call this a and this one b. It does not matter, remember. We could call those interchangeably, but there's no need. So I'm working with 20 squared plus, and here, and you know what? I'll copy it out first. This would be a squared plus b squared equals c squared. After copying, then I can change. It's not an a we're working with, it's 20 because a is 20. It's not a b we're working with, it's a 15 because b is 15 as we've decided down here. And the c value, we don't know, but we can call it x because that's what it's called in our problem. So 20 squared plus 15 squared equals x squared. Nice and easy. I'll copy that out. 20 squared plus 15 squared equals x squared. Now that I've copied, I'll change it. So instead of 20 squared, I can throw that into my calculator, and I find I'm working with, 400 here. Instead of 15 squared, I'll throw that into my calculator and find that I'm working with 225 here. Nice and easy. That means x squared is equal to 400 plus 225. Copy, change. 400 plus 225, throw that into my calculator, 625. Nice and easy. And so I can square root both sides right here, where I copy x squared 625, change, where I can square root both sides. Well, if I'm square rooting both sides, the square and the square root cancel out. I'm working with just x equals the square root of 625. I throw that into my calculator, and I know I'm working with 25. So key here is I'm working with an equation. Whoops, I know I'm working with an equation. So every single line comes from the line above. Copy, change, copy, change, copy, change. That's how you work down. That's how you can show your thinking.